afternoon, everybody. So as Michael just said, I'm part of NXP Semiconductors. We're one of the top 5 semiconductor vendors, and we're specialized in building solutions for securing transactions in the IoT space. We also lead supplier into the automotive space. I want to share a few thoughts with you on the challenges, the security challenges associated in particular to mobile payment. So as NXP, over past years, we've been involved with our technology in securing things in your physical wallet. So banking cards, ID cards, health cards, your passport have chips from NXP that are built with the sole purpose of protecting your assets and your identity. Over the years, of course, we have evolved our technology to make it possible to essentially enable that transition from a physical wallet into a mobile digital wallet. And also, of course, are building solutions to address the security challenges associated to that. How do I move the slides here? This? Yeah. So we are living in a world where more and more devices around us are connected. Connected to each other, connected to the cloud, at home, in our car, in our office space, at schools, hospitals, name it. And in 2018, there will be more than 11 billion such connected devices around us. And this is not going to stop there. It's growing extremely rapidly since the vast majority of all new consumer product designs are integrating in a form or another IoT technology. Many of these connected devices already today have the capability to enable mobile payments. We've seen it in phones with many implementations such as Apple Pay, was named a bit earlier, Alipay in China, Huawei Pay, Xiaomi Pay, name them, not only in phones but also in wearables with companies like Fitbit and Garmin that have also launched similar services. This enables in-store, online, in-app, and peer-to-peer transactions with these connected devices. Prediction is that by 2020, more than 60% of all of us will use a mobile digital wallet in one form or another one. Obviously, there are many questions and concerns on the potential vulnerabilities associated to this. All these connected devices, connected to the cloud, all the secure services being enabled there. How do you make sure that this is done without sacrificing security and privacy? Another key challenge is that beyond the fact that you get so many more connected devices around you, and beyond the fact that these connected devices themselves have so many different communication channels over which they can talk and essentially enable transactions, the whole ecosystem around payment is evolving. Traditional banking implementations, emergent fintech technologies, merging or competing, and eventually, as we already see it in some places, lead to a space where the transaction, the currency is decentralized. There is no such thing in some of these implementations. And we'll see it in the sections that comes after here, or blockchain and Bitcoin type implementation, as an intermediate trusted party that guarantees that the money is truly going to end in the hand of the right person. And even if it doesn't, that's the one who did pay, didn't lose his money. So the challenges associated to securing these transactions are not going to go away, they're going to increase. In parallel to that, with all these connected devices, we've seen over the past years an incredible amount of malicious attacks and hacks that expose sensitive personal financial data. So, multitude of connected devices, changing models on how financial transactions are operating, leading eventually also to decentralized currencies, and more and more sophisticated attacks that we need to counter. Now, the good news is that there are solutions out there that make it possible to secure these connected devices by design. At NXP, we like to call this a proactive approach to security, in opposition to many of the reactive approaches that typically involve complex algorithms that essentially track consumer behavior and, at least in my opinion, lead to poor user experiences. And also, in many cases, not to mention, of course, the potential privacy concerns associated to that. In this proactive approach to security, dedicated secure hardware solutions or secure microcontrollers are integrated into the connected device itself. Their mission is very simple and is unique. It's to protect the data that is sensitive in that device. These hardware security implementations and solutions are the most efficient in protecting us against these evolving, fast evolving, sophisticated attacks. And there are primarily three reasons for that. One is that the actual attack surface of that solution is limited because these dedicated hardware security components are isolated from the rest of the system, have a dedicated protected memory, right? And have just a smaller footprint to attacks in general. But more importantly so, these solutions are built with numerous security features to protect them against tampering or side channel analysis attacks, including power analysis, timing analysis, and many other sophisticated attacks that are implemented today by hackers out there. These are truly actually the only implementation solutions that have not been compromised to date. The other good news is that, well, not only these solutions exist, they are being used by a number of lead technology suppliers in the market. There are examples of this, and quite a few, of mobile payment implementations that use this type of approach. A few I mentioned over here. Same is true for wearables, smartwatches, trackers, but now also make it possible for consumers to essentially pay and have a mobile wallet that they carry on them all the time. And it doesn't stop really at payment. This is something which is extended in many other application domains, which could involve access control, identity, but also just simply secure the platform. And if you look at the most recent example of this, for instance, is the fact that Google on their Pixel 2 has integrated a dedicated secure hardware which exactly has this functionality, right? And make sure that the device can be considered as an extremely safe device to use in a connected world. So to conclude, in a world where everything is connected and when more and more sensitive information is shared over the different communication channels on these devices, it is key that these solutions are secured by design. And that means that the best way to do that is that you have dedicated secure hardware integrated into these connected devices. Make sure that the user device authentication and the financial transactions are done without any hiccups. So that was it for the introduction.
So Vincent Ramito, founder and CEO of UConnect. So what we've done, so thank you, Robin, Charles, an amazing person, great company, NXP. So what we've done, we have taken that piece of hardware, that dedicated chip with its own microcontroller, and we have built a solution architectured around a solution that we know is secure. How do we know that? They've already passed some of the tests. For example, Common Criteria Evaluation Assistance Level 6. The banks today are only using level 4. So you know that NXP is doing something right, and UConnect wants to build on that platform to make sure that it's right. Okay, great, we have the slide up. So what exactly do we have as a solution? We're building an identity product. It's a wearable device, right here on my wrist. But I'm gonna take it out so I can wave it around so at least you get a little bit excited when you see it, right? So this is it, U-Bolt. Come on, let's hear it for U-Bolt. Thank you very much. Thank you, thank you. So what is it? A secure element, wireless charging, fingerprint, biometrics. So we have the first wearable device, fingerprint enabled with biometrics, and very soon we are going to do voice. This is industry leading. There is no other product on the market today that has already announced it. If they're working on it, we're very happy, because then we have competition, and competition is good. More importantly, the ability to take the piece of hardware and ensure that your identity is going to be secure. Now that you have that, what can you do with this identity? You want to give persistency for control. You need to know when your information is getting accessed. And how do you know that? So you heard some of the previous presenters. For example, IBM talked about their 2018 mandate is to protect the personal identity, the digital identity on the blockchain. That's what this is going to do in terms of the digital wallet. The digital wallet, whether it's going to be a MasterCard, Visa, in fiat currency, or whether we're going to talk about the blockchain and being able to protect a Bitcoin directly here in this device to ensure that your paper wallet does not get lost or stolen, because you will have a backup and you will have it right here in this device. In addition to some of the other solutions, typical access control, physical access control, you want to open a door. Logical access control, you want to open a laptop or your mobile app or your banking app. Now imagine that you do not have to type anything in. The system will interface, you will put your finger on the fingerprint sensor and your laptop will open, because it knows who you are, because you have demonstrated and proven with this piece of hardware the trust factor. And that's what makes it very secure. Other solutions include transit. So for example, these typical transit applications right now, you're using cards or tickets, paper tickets. These solutions now can very easily be integrated to deliver on that. So what are the advantages? Biometrics, very unique. A wallet that has multiple currencies. The applications are also e-medical applications, which are very high on security. We're working on a few prototypes right now for a proof of concept. Another concept that is very prevalent right now is the autonomous car. And so we're building out a very secure solution for vehicle occupancy and connected services for a project in Ontario, where we are going to be delivering a solution for 2021. And of course, personalization. Why are these solutions going to be the accepted norm for the business-to-business market? What it means. Today, you have a credit card stolen or lost or destroyed, you have to wait for another one to come in, right? And then you have to go through all of the personalization solutions and processes, whether you're using AI or whether you're using machine learning, it doesn't really matter. But today, these devices have the ability to do over-the-air provisioning. A new firmware changes, a new wallet changes, a new condition changes in your operation, your VPN access codes and your parameters are all different. This will now be over-the-air personalization that will make sure that your information gets secure and protected at all times. Last year, we won the CES 2017 as the best wearable device in the category for wearable devices. We also got an award from Glomo, so we know that we're doing something right, so we're working towards being able to bring this product to the market. We are working very closely with a number of proof of concepts and working very closely with NXP as our preferred partner for our hardware. And we know that when someone engages with UConnect with either the U-Bolt as this form factor or any form factor that we are evolving right now, that your identity will be under your control and you are going to be able to give permission to those mobile applications, services, and application platforms to access your data. Thank you. Robin.
Come join us. Wow, that was wonderful, and I have so many questions. But so over the air, so we know you use this guy in your wearable. What else is in there? Like, give us sort of like what's doing the over-air provisioning. What's
So what we do is, so for example, there will be a personalization platform, and whether we use the personalization platform from NXP or we have third-party personalization platform. You register yourself, just like as if you would register for a bank account or a credit card. Once that's done, then imagine your Visa card and your MasterCard will now be embedded in this device. You will not need a piece of plastic anymore because this becomes your credit card. Your loyalty card, for example, we haven't talked to Starbucks yet, so if anybody in the room that works for Starbucks, please come see me. I would like to talk to you. We will be able to take loyalty programs and embed that directly into the bracelet. Now your loyalty card would automatically be accepted, your points get deducted or added, and you will be able to make the payment with the same product. The concept of frictionless transaction, that's where we're going.
So back to Charles for a minute. We've seen not as fast, I think, an adoption of mobile payments in general as we'd like. And I think, I don't know if NXP looks at some of that data, but do you have a sense, like, what's the hurdle that we have to get over before we're all wearing a bracelet and swiping our way through?
So it's very geographically, there's a lot of geographic dependencies on this. I would say in the US in particular, probably consumer experience and consistency in the experience is the biggest hurdle. People don't understand what they have to do anymore. They need to swipe, they need to tap, they need to sign. They can use a phone, they can't. It's too complicated. It's also, at least that is improving now. There was a lack of places where you could actually use the technology also in the US. That is not so much true in other areas. If you look in China, for instance, I mean, everybody's familiar with Alipay and WeChat Pay. What's happened there in the last 2 years is just mind-blowing. It's huge. It's hundreds of millions of people that use their mobile wallet every day and multiple times every day. Similar things we see in Japan. We have a number of initiatives in China where also transit and payment is being used. And transit is very intuitive for consumers to use. And instead of using a plastic card to access their subway system, they use their phone. They use it twice a day. They can top up their transit card with their payment card. It just becomes overall a better experience. So it's a matter of time, I would say. Yeah.
So when you top off your device, how do I get more money on my wearable?
Basically, you'll be able to just go online on on any app, whether it's a mobile app, whether it's your desktop, and you say load $200, it shows up.
And so, of course, you have this, you have to remember to wear your wearable, or you want to send your husband to the bank, heaven forbid, instead of you, well, forget the bank, but you want to switch, can you switch bracelets? Can you multiple fingerprints? Do I?
You cannot switch bracelets. This is identity-based. But of course, you could have multiple fingers. And what happens if someone chops off your hand? The finger is dead, so you can't use it, right? What if someone drugs you and they say, oh, I'm going to take your identity information. When we enable voice activation, you will have to do voice and fingerprint. So we've thought about some of the use cases, and we've already implemented a certain amount of use cases to be able to bring that usability and the use factor into the wearable world and being able to offer multiple aspects of the solution.
Yeah, and I think what you said about office access, computer file access, so if you think about one wearable, and I know we're going to talk again when we talk about the wearable market, just how much of your, I think we believe that one of the big areas where there's room for wearable to really enter the market is in the office space, and you're seeing it with the reincarnation of Google Glass, and you're seeing it with a lot of wearables. So how many people out there are actually building hardware solutions? Like, okay, so now let me ask, what are you doing at CES? It actually seems there's actually, CES has a design and sourcing pavilion, and I urge you all to spend some time over there. So use my imagination. How many other form factors will I see? I know we've got a ring, right, out there now. The curve is out there, and the other black ceramic ring that from Visa and from MasterCard.
There are quite a few wearable type devices. I mean, some of the ones that we are exploring right now is, of course, the ring form factor, a pendant that just hangs and still has all of the intelligence built into it. Of course, as the form factor changes, your biometrics and the use cases of the biometrics changes with it. So for example, if it requires the bracelet to touch your skin, when the skin contact is broken, that means the identity is broken. So you will have to re-identify yourself by putting on your fingerprint again. So there's certain ways in which the form factor will change. One form factor that I'm working on right now is law enforcement. So if you imagine for a minute, low-end offenders, they wear an ankle bracelet, right? Nice and cool, but not really easy to have on at all times. Granted, they deserve that. But now they want to change, Manufacturers want to change the style and type of wearables. So now they're looking at a product like U-Bolt to be able to build as an offender wrist bracelet, not an anklet. So another form factor that we're also investigating right now, it's something that can be worn as a patch, long term.
So this is my last question, then we'll open it up to audience. Earlier today, we heard from former Governor Pawlenty and other speakers talking about the balance between convenience and privacy. Clearly, let's say my bank decides to give me my wearable, or my payment card gives me a wearable. What am I giving up? What data and how much, as you spread into office access, does my boss know where I am all the time?
You answer that first, and then I'll take it.
Well, it depends very much on how the whole system, of course, is implemented. At its dumbest, essentially, it's just a replicate of what you have in a plastic card into something that you carry on you with a richer UI that gives you a better, more convenient experience. It could go beyond that. And it's not only in the space, coming back to your previous questions, not only related to mobile devices, wearables, it's also your car. You're going to be using your car to make payments in car experiences where you will pay for your gas without getting out of your car. You will pay for upgrades of your car directly through the connected devices that are integrated into your automotive.
Yeah, and I think it really gets interesting. Not only will you be sitting in your car making payments, but your car will be making payments to your gas pump, and you guys will be there as well, right? So
Absolutely.
My car will have its own wearable. It's really like fascinating to me, the number of devices. I would like the handbag. And of course, if you remember, if you were at CES a few years ago, there was a handbag that locked shut after you spent your allotted allowance that you set up. So that's the one I want when I'm in Vegas. Anybody in the audience, questions, thoughts, comments? And I'm gonna jump down, and you guys
Sure, go ahead,
the rest.
please. Yes.
Why don't you tell us who you are, Mike? Here, Mike will do it.
Okay, what do you got? Yeah, my question is in regards to the U-Bolt. Do you guys have plans to do integration with two-factor authentication, such as Google Authenticator, Authy, or Duo Mobile applications where you might have a cell phone authentication and fingerprint?
Okay, so the question was around additional multi-factor authentication. Absolutely. So what we have done now, so today we have a complete API. We have a toolkit that basically, because of it's a secure element, and we will control to a certain degree how the domains in each part of the secure element is managed. So we will offer a set of APIs to programmers, to developers, to business, in-house computing, and they will be able to use multiple levels of access. For example, one of them we're working on right now is FIDO. So we will build the U2F ability directly natively within our code. And so we will offer that as another level of access.
So today's topic is cybersecurity and privacy, right? I think when I'm thinking that loud, I mean, we should have cyber physical security and privacy. Look like you guys mainly addressed. Probably if I would say is more physical, close to physical security. How about, can you comment really on cybersecurity and privacy? Thinking about Equifax and Yahoo, if you want.
Want me to take that?
Yeah, right, yeah.
All right, so when we talked about digital identity, I mean, that is cybersecurity, right? Cybersecurity is focused on only one thing, right? A person's identity has to be captured in a certain format, and whether that format is in a platform. For example, you're familiar with the e-passport or the e-residency card from Estonia, right? Well, that is basically a chip that's embedded on a card or embedded in a passport. And that chip is not as sophisticated as this chip. How do I know that? Because of what they're using. Because it recently got hacked, right? Right. So now what we have is we have the ability to take. U-Bolt is only one form factor today that we have brought to the market, because we had to choose what way that we would bring something to the market and have it readily acceptable for the general audience, right? In our business-to-business world. So today, the identity of a person stored here can now be managed exclusively by any agency, government or non-government. So the identity that's stored in here can be used to manage payments, but could also be used to manage a passport, a driver's license, health card. It could also be used, for example, in cybersecurity to protect someone's health records or health information. That could also be used. So the personalization part of it comes with the identity and being able to use the identity to manage how your data is going to be protected, whether you're in the cloud, whether you're on physical, whether you're on a mobile, or whether you're on a wearable device. And so when we look at, for example, everyone has been using their smartphone to do all kinds of things with it. And granted, the smartphone, we all love it, and we like to use it, but sometimes it becomes more of a friction to take that phone out and have to do something with it. Am I on the wrong path or on the right path? The server will be the server for the business-to-business platforms. So, for example, if a government wants to implement a driver's license solution or a transit system, a local regional community wants to build a transit solution using this bracelet, their platform, internal platform, closed loop, will be managing this bracelet, and they will be managing all of the personalized information. So the cybersecurity aspect of it will be protected behind their firewall. And they're the ones who's going to manage the data. They're the ones who's going to authorize. They will do all the personalization, and they will also be able to do whatever else they need to do to make sure that they control it. Is that helpful? Good.
Thank you. I think that's helpful, and I think if you stick around through the blockchain panels and you see how all these pieces of the puzzle start to fit together, not without trial and error, and probably not without some people getting hurt, but I mean, already here, all day long, I've gotten card not present notification every time I spend a dime, and I'm sitting there, okay, I like that. They're actually giving me some useful information in exchange for probably a lot of my privacy. But I want to thank Charles and Vince for sharing that down and dirty look with us, and invite Michael Casey back.